Quantum psychology sounds like the title of an esoteric novel, although in fact, this expression hides a very concrete scientific drama in which psychology, mathematics, and the strange world of quantum theory meet. The question here is not whether electrons in the brain jump the way the protagonists would like to believe, but why our thoughts and decisions sometimes behave as if they obey not classical logic but the logic of probabilities from quantum physics. At the end of the 20th century, the American psychologist Jerome Busemeyer, a specialist in decision theory and a professor at Indiana University, encountered a puzzle that did not fit into the usual models of rational choice. People changed their answers in surveys simply depending on the order of the questions, as if the very act of measurement influenced the result, and classical probability theory could not describe this accurately. This effect resembled the famous measurement paradox in quantum mechanics, in which observation changes the state of a particle, and Busemeyer and his colleagues took a bold step. They borrowed the mathematical apparatus of quantum theory to describe cognitive processes. A field arose that today is called quantum cognition, and it does not claim that the brain is literally quantum. It claims that our uncertainty, contextuality, and paradoxical decisions are most conveniently described by the same mathematics as the world of microparticles. Imagine a simple room with a computer, where ordinary people, students, and office workers sit down to answer surveys about politics, ethics, or food preferences. And suddenly, their answers begin to dance to the rhythm of quantum uncertainty. When first asked about support for the death penalty, and then about its inhumanity, 70% say no to the first and yes to the second. But if the order is reversed, these numbers flip, as if the very measurement is rearranging the probabilistic landscape of consciousness. Professor Jerome Busemeyer and his colleagues in the 2000s carried out a series of experiments on thousands of participants, using the method of sequential measurements. First one binary question, then another that contradicts it, and comparison with control groups without rearrangement. They applied Bayesian statistics for verification, and the quantum model predicted the order effect with up to 90% accuracy, while classical theories produced only a mess of contradictions. This paradox, called a violation of the order equation, became the foundation of quantum cognition, showing that our thinking is not a rigid machine, but a living field of interferences where context gives birth to reality. Translated into simple language, classical psychology assumes that in the head, there is something like a box with prefixed answers, and the survey only pulls out an already prepared little ball labeled yes or no. The quantum model, however, assumes that before the question, a person's state resembles a mixture of possibilities, a kind of cloud of probabilities, and only the act of questioning, like a spotlight, makes one option real and extinguishes the rest. The young researcher Zhengyuan Wang, then still a graduate student at Indiana University under the supervision of Jerome Busemeyer, led an ambitious international project that gathered thousands of participants from the USA, Europe, and Asia in online and laboratory surveys to once and for all test whether quantum mathematics can predict the whims of the human mind better than old classical models. Imagine the scale. Volunteers all over the world answered chains of questions such as first support for military intervention and then its ethical cost, or preference for coffee over tea in different sequences. And the group recorded every violation of logical order, using complex algorithms to analyze the data in real time, as if catching the interference of waves in a vast cognitive ocean. The results blew up the field. The quantum formula of order equality perfectly described the shifts in answers in up to 90% of the cases where classical probability bogged down in contradictions, proving that our decisions are not static balls in an urn, but dynamic superpositions collapsing under the beam of context. It turned out that a formula taken from quantum theory describes with surprising precision how the rearrangement of questions systematically changes answers, as if there were in consciousness its own version of the principle of superposition and collapse. Against this background, the idea of the subtle world begins to sound different. Instead of a mystical parallel reality, it may be an invisible space of states of our consciousness that exists before words and decisions, and obeys not classical, but more subtle probabilistic regularities. The physicist and philosopher Harald Atmanspacher, who studies quantum approaches to consciousness, proposes to consider the mental and the physical as two levels of one reality that manifest according to different rules, but are connected through common structural principles. Harald Atmanspacher, a Swiss physicist with a rich path from studying lasers and chaos in stars to the mysteries of the human mind, began his career at the prestigious Max Planck Institute in Germany, and then moved to the Institute for Frontier Areas of Psychology in Freiburg, where for more than 30 years he has been uniting physics with psychology. His life resembles a bridge between worlds. He edited books about great physicists such as Wolfgang Pauli, wrote a chapter for the Stanford Encyclopedia about quanta and consciousness, became an honorary member of the Jungian Analytical Psychology Society, and even devised theories about how new levels of reality are born from old ones but do not dissolve in them. This quiet thinker, whose works are cited by thousands of scholars, turned dry equations into living questions about why our thoughts sometimes seem connected with a world beyond the body. Atmanspacher looks at mind and body not as enemies or as master and servant, but as two sides of one coin. Inspired by the old ideas of Pauli and Jung, at the foundation lies something neutral, neither pure matter nor pure thoughts, from which both worlds grow, as if the roots of one tree give rise to different branches. These branches live by their own rules, the body by the laws of physics, the mind by the laws of feelings and meanings. But they are linked by a common framework, just as in quantum physics. Waves and particles dance together, creating patterns such as synchronicity, when coincidences are not random but carry deep meaning. He relies on mathematical models of quantum theory and on psychology, showing that without this common foundation, the correlations between thoughts and events remain a mystery, and with it, everything falls into place like a puzzle. The modern physicist and cosmologist Max Tegmark, a professor at the Massachusetts Institute of Technology, takes another radical step by proposing the mathematical universe hypothesis, in which reality is essentially a mathematical structure. Continuing this idea, he considers consciousness as a special type of informational pattern, as a way in which information feels itself. And then, the subtle world turns out to be not somewhere outside, but in the very way information is organized in the brain. Tegmark's biography itself resembles a storyline. He was born in Sweden, made a career in astrophysics, worked on questions of cosmology and the structure of the universe, and then turned to the problem of consciousness, as if his entire scientific trajectory had been a road from outer cosmos to inner cosmos. His ideas often provoke debate, but in the scientific community, they are taken seriously as a consistent continuation of the question of how deeply mathematics is woven into the fabric of reality and our experience. If one combines the views of Busemeyer and Tegmark, an interesting picture emerges in which quantum models help describe the behavior of our decisions, and the mathematical approach to consciousness suggests that experiences and thoughts may be manifestations of general structural laws similar to physical ones. From this perspective, the laws of the subtle world cease to be only a metaphor and become a hypothesis about what forms information can take when it is organized into a living, feeling pattern. So that these ideas do not remain beautiful philosophy, it is important to look at specific exercises, the first of which can be called observing probabilities. During the day, one can choose a single situation of choice, for example, whether to answer a message or not, and honestly note in one's mind all the options that arise before the action, as if laying out the spectrum of possible states in front of oneself. And then consciously track at what moment, and under the influence of which inner question, the internal spotlight collapses this cloud into a single decision. Such a skill of noticing the entire hidden spectrum before the decision helps to see one's own cognitive regularities more clearly. The second exercise is related to the fact that quantum cognition shows that the context of a question changes the answer, and this can be used as a tool. Before an important choice, it is worth formulating at least two different versions of the question to oneself. For example, not only what will I lose, but also what can I gain? and noticing how different internal scenarios flare up in different ways. This simple action, when a person changes the angle of the question, literally rewrites the probabilistic landscape of thought. And in this sense, the laws of the subtle world operate through language and attention. The researcher Alexander Wendt, a well-known political scientist and author of a book on the quantum mind in the social sciences, proposes to consider social reality as a gigantic network of cognitive states that can also behave in a quantum-like way, in the form of superpositions and instantaneous state changes under the pressure of events. Then the collective unconscious, about which Carl Jung wrote, can be imagined not as a mystical archive, but as a complex field of states in which each of us is part of a common wave of meanings. Alexander Wendt, a Canadian-American political scientist who turned the world of international relations upside down with his 1999 book about how social ideas shape state politics, suddenly in 2015 released a bomb titled Quantum Mind and Social Science, in which he boldly declared that human consciousness is not just brain chemistry, but a genuine macroscopic quantum phenomenon, as if we walk around as wave functions full of superpositions and entanglements, as if our consciousness is a blurred quantum wave full of parallel possibilities and connections, along which we move in everyday life. Imagine this professor at an Ohio university, previously known as a constructivist, who won a prize for the best book of the decade, now giving lectures about how our intentions are the collapse of a wave function in the brain, and social structures such as states are shared superpositions of collective thoughts, where each person's will becomes a force choosing reality from a multitude of possibilities. You may ask whether, based on this idea, one can say that it is important for each of us to be friendly and supportive inside so that the whole state becomes the same. Yes, based on Alexander Wendt's model, this is a logical conclusion because he describes social structures as collective superpositions of minds, where individual states become entangled through language, culture, and interaction, forming the common wave function of society. If the intentions of each person are mini collapses of the wave function, then friendliness and support within one person enhance positive probabilities in the collective field, like a drop changing the interference of the whole wave. The will of the individual becomes a contribution to the choice of reality for the entire state, where egoism collapses into chaos and empathy stabilizes harmonious states. Wendt starts from the problem of consciousness that torments the social sciences. Classical physics sees us as machines, but does not explain where our free will and feelings come from. And then he turns to a quantum theory of the brain, inspired by works such as the orchestrated theory of Hameroff-Penrose about microtubules in neurons, where quantum effects persist longer than previously thought. He proposes a simple model. Thinking is a wave function with probabilities of the future. Experience is its collapse at the moment of choice. And will is the force that decides which option to realize. And this extends to society, where languages entangle people's minds, creating invisible connections such as collective fears or hopes that influence history. Wendt believes that in every particle of the world there is a simplest spark of consciousness, or proto-consciousness, as the basis for our free will, because this allows the mind not to be a slave of physics, but to choose among many paths. He has even organized intensive training programs in quantum social science so that students and scholars can learn to apply these ideas in practice and change their view of society. The neurophysiologist Karl Pribram, in his holonomic model of the brain, proposed to consider memory not as a set of separate cells but as a distributed pattern resembling a hologram, where each part contains information about the whole. This image resonates in a striking way with the idea of the subtle world as a field in which every point carries the imprint of larger structures. And perhaps that is why sudden insights sometimes feel like the instantaneous emergence of a holistic picture rather than the slow assembly of a puzzle. When a listener encounters such ideas, an inner question about the reality of his own thoughts and feelings often arises. And this is precisely the moment in which a personal experiment begins. And in such an inner experiment, a space of shared reflection is very helpful. Therefore, if these themes resonate, it is helpful to support the channel, to leave a like and a subscription. In this way, a community is created of people who try to apply these subtle regularities to real life, and not only discuss them in theory. Interestingly, a number of models similar to quantum cognition are already finding applications in economics and marketing, helping to explain and predict situations where classical rational models fail, such as strange consumer choices or framing effects in advertising. This shows that what seems like abstract philosophy is slowly turning into a set of working tools. And here, the combination of skepticism and openness is important when new ideas pass through the filter of experiments. In philosophical terms, the key question remains whether consciousness is a product of matter or a fundamental side of reality. And quantum approaches to consciousness only emphasize the depth of this mystery, proposing different scenarios, from microtubules in neurons to non-material levels of description. So far, no theory has received final confirmation, but the very attempt to connect the laws of the micro-world and the regularities of inner life opens a space in which the notion of the subtle world becomes a field for rigorous, albeit very bold, hypotheses. The law of the subtle world in a practical sense can be described as the law of careful choice of context, because, as experiments in quantum cognition show, which question is asked and in what sequence determines the trajectory of our thoughts no less than objective facts do. When a person consciously shapes these questions to oneself and to the world, one is in fact retuning one's internal probabilistic landscape, shifting the maximum of probability toward those decisions that better correspond to one's values. Another important line in contemporary science of consciousness is connected with interdisciplinary centers where physicists, psychologists, and philosophers work together. For example, consciousness studies programs at major Western universities include seminars on quantum interpretations, information theories, and neuroscience. These platforms show that the topic of subtle regularities of the psyche has ceased to be marginal. It is becoming a meeting place for different languages of describing reality, from equations to personal experiences. At the intersection of these approaches, a new understanding of responsibility is born. If consciousness can indeed be considered a special informational pattern, then every action, word, or even inner decision becomes a contribution to the overall picture, like adding a stroke to an interference pattern. Such a view adds a little reverent seriousness to everyday choices, because even a small shift in the tuning of attention can in the long term change the wave of meanings in which a person lives. At this point, a call to dialogue is especially appropriate because quantum psychology and the conversation about the subtle world inevitably touch on each person's personal experience, and it matters which examples from one's own life a person recalls when hearing about superposition of feelings or about the influence of observation on state. Write in the comments your stories about strange decisions or sudden insights. They may become material for subsequent analyses of such subtle regularities. And finally, there remains a big question that unites physicists, psychologists, and philosophers. If the laws of the micro-world, mathematical structures, and our inner experiences are indeed connected, then might what is usually called the subtle world simply be a more complete description of reality, one that includes the observer and his choice and his attention? Perhaps we live in a universe where every act of conscious choice slightly changes not only a personal story, but also the common wave of meanings. And then the study of these laws becomes not only a scientific occupation, but also a very personal art of tuning one's own trajectory. Sometimes a single unexpected episode is enough for an entire theory to suddenly become personal. One of Jerome Busemeyer's students recounted how, in his student years, he confidently considered himself a rational skeptic until he participated in an experiment in which it was necessary to answer simple questions about one's preferences. And only after the survey did he see that merely changing the order of the questions made his own answers begin to contradict each other, as if there were several different versions of himself inside. That day, he first felt that the subtle world about which philosophers speak might not be a metaphor about spirits, but a description of that shaky inner domain where there is still no final decision, but there are already many possible trajectories, each of which is waiting for its observer's question. In contemporary scientific history, One of those who approaches these subtle questions with particular care remains Max Tegmark. He emphasizes that even the boldest ideas about consciousness as a mathematical pattern must pass the same filter as cosmological models do. A test of internal consistency, agreement with observations, and the ability to make predictions. His path from calculations on the cosmic microwave background to reflections on the structure of consciousness shows that the conversation about the subtle world does not at all have to mean a retreat into mysticism. On the contrary, it can mean an attempt to place under a magnifying glass those layers of reality where there are not yet familiar measuring instruments, but there are already rigorous questions. If one looks at the laws of the subtle world through the eyes of a psychologist who works with quantum models, they begin to resemble not mystical commandments, but rules for working with probabilities and contexts. One of the key principles here can be formulated as follows. The inner state does not simply react to the world, it constantly remains in a superposition of possibilities, and that on which attention lingers begins to intensify, gaining density. Imagine a room where dozens of thin threads lie across the floor, each of them leading to a particular outcome, and each thought, each decision is a step along one of these threads, and before the step, they all exist on an equal footing, while after the step, one of them turns into a path along which it is already easier to walk again. From a practical point of view, this means that the laws of the subtle world manifest in the simplest everyday decisions. For example, a person who every evening chooses how to devote the last minutes before sleep to a news feed full of anxiety, or to quiet reflection on the day lived, as if performs a small quantum measurement of the inner field, fixing either a wave of worry or a wave of clarity. Over weeks and months, these microscopic measurements add up to a stable pattern. And then there is no need to invent metaphysical explanations. It is enough to see how a frequently repeated choice turns into a habit, and a habit becomes that very invisible law of the subtle world that a person seems to feel with the skin. One of the surprising conclusions reached by researchers of quantum models in psychology is that our contradictory states do not necessarily need to be immediately reduced to a single one. In quantum language, superposition is permissible and even natural, and a person can simultaneously love and be angry, want change and fear it, and the task is not to forcibly choose one side, but to honestly acknowledge the entire palette of states before directing the spotlight of attention. In one therapeutic story, a client who had been trying to suppress her anger for many years described relief precisely at the moment when she allowed herself to hold two states at once, care and irritation, and suddenly discovered that from this tense but coherent experience there arose a more mature decision rather than the usual splitting. Returning to Tegmark's biography, it is striking how his interest in the structures of the universe gradually leads him to the structures of subjective experience. In his lectures, he likes to emphasize that he does not see a fundamental chasm between equations describing galaxies and equations describing the dynamics of neural networks. In both cases, the question is, what forms information can take? For us, this means that the subtle world may be that place where physics, psychology, and personal history meet at one point, where a person asks oneself who one becomes when one chooses again and again the same thoughts, the same reactions, the same images of oneself. To feel this reassembly better, one can try a small practice of a conscious script. In the evening, it is worth writing out a short fragment of a situation that now seems like a dead end, for example, a conflict at work or chronic procrastination of an important task, and then deliberately invent 3 different continuations for it without evaluating them as right or wrong. What matters is not which script is chosen, but the very exercise of stretching the wave of possibilities, when for the first time in a long while, a person sees that their inner film can have several editing options, and thereby ceases to perceive the current storyline as the only possible one. It is curious that in the history of science, disputes around quantum theory have always been accompanied by questions about the role of the observer. Niels Bohr and his colleagues emphasized that one cannot speak of the properties of an object outside the context of measurement, and this idea unexpectedly resonates with the way the view of personality is changing in psychology. Personality ceases to be something frozen and becomes a process that manifests in each act of self-observation, in each inner commentary on what is happening. And then the subtle world is not somewhere above us, but is precisely this transparent medium of self-observation, which a person either clutters with automatic judgments or clears with attention and curiosity. At this point, it becomes especially clear that the scientific conversation about quantum psychology needs balance. On the one hand, it is important not to slide into naive promises of instant magical transformation. On the other hand, it is no less important not to dismiss new models just because they touch familiar notions of free will and reality. The personal research path of each listener can begin with a very simple step. For example, with a week of observing how the context of questions changes their own decisions. And finally, the deeper one peers into these intersections of quantum theory and psychology, the more insistently the question sounds of whether it will ever be possible to build a unified map where equations describing superposition of states coexist just as naturally with human stories about how one word, one meeting, or one inner pause changed the trajectory of a life. It may turn out that the laws of the subtle world do not promise us complete control or the fulfillment of all desires. They merely remind us that each act of attention, each honest looking into one's own states, each new conscious decision slightly retunes that invisible wave along which we move. And if there is a desire for such topics to be explored further, you can share your observations in the comments. Perhaps it will be your story that becomes the next example of how a subtle regularity unexpectedly manifested in the most ordinary human life.